Julie initially invests $35,000. The interest rate per annum is 4%. At the end of each year, she contributes an extra $1,500. The balance is calculated once per year. In part A, we just need to find the balance at the start of the second year. So it's a very simple mathematical calculation. So we know that there's 4% of interest earned. So we just need to calculate what 4% of 35,000 is. So 4% as a fraction is 4 on 100, and then we multiply it by the amount, and that should read 35,000, so there should be an extra zero there. But it's 4 on 100 multiplied by 35,000, which gives us 1,400. So in the first year, she earned an extra $1,400. The balance is then going to be the 35,000 initially invested, plus the interest earned of 1,400, plus she makes a contribution of $1,500 at the end of the year, so 1,500 is added on as well. And we end up with $37,900. What you should realise is that in this question, it's basically just an application of a combination sequence. We have an interest rate, and that can be re-expressed as an R, a common ratio. We also have $1,500 added every year. So that there we should recognise as just being the D, the common difference, or a common amount that's added or subtracted each year. So this kind of question is just an application of a combination sequence. A difference equation of a combination sequence is always written in this format. If we're after any given term, we have R multiplied by the term before, plus a common amount or a constant amount, D. And we have a starting point where T1 equals a certain figure. So that's our general setup for a difference equation that is of a combination sequence. R. It's always in this format, 1 plus or minus whatever the percentage is over 100. So in our case, it ends up being 1 plus 4 on 100 to give us 1.04. D, what is it that we're adding or subtracting for each term? And it's 1,500. A, where are we starting from? And it's 35,000. So now all I need to do is throw that into this format. So there's my R, 1.04. There's my D, 1,500. And T1 is the first term, so 35,000. So that is the answer that we're looking for. That's the difference equation that explains what's going on here. Okay, use the difference equation to calculate the balance as at the start for the first 5 years. So to begin with, we started with 35,000. So T1 equals 35,000. T2 is going to be equal to 1.04 times the term before, so T1 plus 1,500, and of course I've just written it again here, except for I've subbed in 35,000, and ended up with 37,900. And I repeat that process all the way through, so you can see T3 is there, T4 and T5, and that calculation is straight and easy to do. Of course, the problem with a difference equation is that if we're after the 100th term, I need to know what the 99th term, which relies on knowing the 98th, 97th, 96th, 95th, and so on all the way through. So to calculate the balance after a large amount of years, it's quite cumbersome, and it's not the technique that you would use. Instead, you'd want to make use of a general rule. And with this general rule, all you want to be able to do is substitute a value of n in for the amount of years, and then that will spit out the answer. The general solution for a combination sequence is given by this rule here. So if I look at that, my values of R are the same as the previous steps in question. So R is 1.04, D is 1,500, and A is 35,000. So if I sub those into this rule, I'll get this. Now, that is an acceptable answer. There's nothing wrong with that. If you put that in as your answer, you'd be 100% correct, and you'd get all of the marks that were available. However, when it comes time to using this rule, you can see it's quite cumbersome. You've got two places where you have to substitute n, and you've got a lot of fractions going on here as well. We can clear this up a little bit with our CAS calculator. So in the next line, which looks a lot simpler, the way I went from this line, the second line, to this third line was just to put the right-hand side into my CAS and let the CAS simplify it for me. So the right-hand side, I had 35,000. I then multiplied by 1.04. Then that was raised to the power of n minus 1. And I moved across, I go plus, and I bring up the fractional template, and it's 1500 at the top. And I'm multiplying by the bracket 1.04 to the power of n minus 1. And just move my cursor across. This is really important, so it's no longer in the power part. Minus 1. And then down the bottom, I've got 1.04 minus 1. All right, so that's all the right-hand side. So it's just this part here. And if I hit enter, you can see it gets simplified, and there's a simplification. And I write that down as my answer here. Much easier. All right, in step E, we're going to apply it. So we need to find the balance after 12 years. So, of course, I've worked out what T of n is, the general rule for it. So T of n is equal to this. And, of course, the only thing I need to substitute into that is the value of n. We're after T12, so I substitute 12 into it, and I end up with this figure here, $74,110.40. Just a little trick, when you're using your CAS, you've obviously generated this rule here. This rule has been simplified for us, so it's nice and easy to use, but there's actually more accuracy. That line is not exactly equal to this. All right, there's greater accuracy with the decimal points. So when it comes time to subbing in n equaling 12, what I can do is simply go up with my cursor to select the formula, go Control C to copy it, and now go Control V to paste it. So it's pasted, and what you can see that there's greater accuracy here. So this 69711.5, you can see that the 0.5 is in fact 0.53, blah, 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 blah. So there's much more accuracy in here. Now to do the substitution, so I want n equaling 12, I just go into here with my cursor and select, or replace n with 12, hit enter, and I get my figure. So doing the copying and pasting does two things. Firstly, it's quicker and easier for you to do, and secondly, it gives you the rule that you're going to use with much greater accuracy. So you can see here it's $74,110.40, and that's what I've written.